Instead of relying on relay ladder logic, we will demonstrate how a ladder for Allen-Bradley PLC can be designed to control a hydraulic circuit. As with all electrical control libraries in Automation Studio, the PLC library allows users to build a logic control in Automation Studio. Although this PLC circuit is not intended to be downloaded in the actual hardware PLC, it will allow the user to design, simulate, and validate the PLC circuit with other circuit technologies within Automation Studio. Using the same hydraulic circuit as before, we will add proximity sensors, which detect when the cylinder has completely extended or retracted. Using the valve's builder function, we will change both the lever and spring to a solenoid. Now, we are ready to design our Allen-Bradley PLC. Starting with the rung, we can place it on the diagram and size it. The contacts are also added simply by dragging and dropping them from the library to the diagram. For this circuit, we will also incorporate a timer, specifically a timer on delay. To complete our ladder, instead of going back to the library, we can use components that are already on the diagram. Components are connected by clicking from one port to the next. Next, we take out the input and output Allen-Bradley PLC cards. And to complete our input devices, we need the power supply and the proximity switches, which correspond to the in and out sensors above. For the output, we need two solenoids. We will call them Sol 1 and Sol 2. These correspond to the solenoids on the valve above. The question marks indicate that there are quite a few variables that need to be assigned. Beginning with the valve, we see that the solenoid on the left is identified as Sol 1 and the one on the right as Sol 2. So, we assign these variables respectively. The proximity switches are linked to the in and out sensors. Notice that the input devices are addressed as follows. The in switch is linked at in 0 and the out switch at in 1. The output devices are addressed as Sol1 linked to Out1 and Sol2 at Out3. By selecting both tag names, changes to both can be done at the same time. The last contact needs to be linked to the timer. The timer can be reconfigured by changing the preset time delay from 10 seconds to 3 seconds. And, like other components, we can also change its displayed information. Now we can simulate our circuit. Notice that as soon as the cylinder has extended and activated the out sensor, the timer begins counting to 3. Only after 3 seconds will the cylinder retract. When the in sensor is activated, the valve activates and the cylinder extends to the out position again. Pulling out the plotter gives us a better idea of how the system is behaving. In just a few minutes, you saw how quickly and easy it was to build an Allen Bradley PLC ladder and use it to control a hydraulic circuit.